Hello friends, I welcome you on my channel. Today we are going to discuss a problem from the real number from exercise 1.1 question number 4. This question was asked by one of our viewer. He found the question a little bit difficult. Let me make the things clear. The question is very simple. The thing how to do. Before moving to the question, you should watch my previous videos in which I have discussed about the Euclid's division lemma. Then you can easily do this question. Here we have a question. The question is, use Euclid's division lemma to show that square of any positive integer is either of the form 3m or 3m plus 1 for some integer m. Try to understand. Question is very simple. Let's move to the solution. Let n be any positive integer and b equals to 3. Then by Euclid's division lemma, we have n is equals to 3q plus r provided r is more than equal 0 less than b. This is the Euclid division lemma. Therefore n is equals to 3q plus r. The value of r is between 0 and b. It is either more than 0 or equal 0 or less than b. That is r is equals to 0, 1 and 2 according to division lemma, because value of r should be either less than this or 0. That means 0, 1, 2. We can't write 3 less than this. Here we have 3 possible values of n. These are n is equals to 3q, 3q plus 1 and 3q plus 2. Now, according to the question, squaring both sides. Case 1. N is equals to 3q. So because this is the first case, n is equals to 3q, we need to square both sides. N square is equals to 9q square. Next line, n square is equals to, we can take 3 common, so it may be 3q square. And this 3q square can be taken as another integer. Therefore, n square is equals to 3m, where m is equals to 3q square, some integer. Now let us move to the case 2. N is equals to this second number, 3q plus 1. This second number is the case 2. Now we need to square both sides. N square is equals to 3q plus 1 whole square. You know how to open the whole square of any number. A plus b whole square is equals to a square plus 2ab plus b square. This you know very well. We'll apply this formula in this section only, and let's see what is your answer then. We have n square is equals to 9q square plus 6q plus 1. From this part we'll take 3 common. N square is equals to 3 taken common, so it is 3q square plus 2q, and finally this plus 1. Now this will be some another integer m, or n square is equals to 3m plus 1. After this we are going to discuss the case 3. We have discussed this one. This is second case. Now we'll discuss the case 3. Case 3. N is equals to 3q plus 2. Again we need to square. We have n square is equals to 3q plus 2 whole square. We have already discussed the identity a plus b whole square, so it will be 9q square plus 3 to the 6 to the 12q plus 2 to the 4. Now what we need to do, this 4 will be written as 3 plus 1. Let us see what is our next step then. Nine q square plus 12q plus 3 plus 1. Now from this part you need to take 3 common, because you can see 3 is common everywhere. So 3 is taken out from the bracket. We have 3q square plus 4q plus 1, and finally this one outside which was written here, this is written here. So this is some other integer, or n square 3m plus 1, where m is equals to 3q square plus 4q plus 1, some integer. Now you can see the square of n is either in the form of 3m plus 1 or earlier written 3m. Now from all the cases we can write n square is equals to 3m or 3m plus 1, and this is our solution. Hope the solution is clear to you. Now we move to another question, question number 5 from the same exercise. Let's see what is the question. Friends, next question is question number 5 from Ncert book exercise 1.1, and the question is, use Euclid division lemma 9m plus 8. Use Euclid division lemma to show that cube of any integer is of the form 9m plus 1 or 9m plus 8. Let's see the solution. Solution is very simple, as we have done the earlier question. In the previous question we have done the same thing, we will do the same. And the thing is, don't get confused by looking this 9. You may be thinking b is equals to 9. Don't take b is equals to 9. That will create a problem because we have to do question very long. Better you take n is equals to 3q as we have taken in the previous question. Here is the solution. Let n be a positive integer and b is equals to 3. Therefore, from Euclid division lemma, we have n is equals to 3q plus r, provided 0 less than equal r less than b. Here the possible values of r is equals to 0, 1 and 2. Thus we have n is equals to 3q plus 1 or 3q plus 2 for some integer q more than equal 0. So we have here three cases: n is equals to 3q, 3q plus 1 or 3q plus 2 for some integer q is equals to 0. Now let's see all the cases one by one. Case 1, n is equals to 3q. According to the question, taking q both sides, we have what we need to do. We need to just take the cube of both the side. This side and this side, we'll take a cube. So this is n cube is equals to 3q. Here we have n cube is equals to 3 3s are 9 3s are 27 q. Now you can see 27 means 9 into 3, 27, 9 3s are 27. Therefore we will write 9 into 3q. Now this number will be written as another integer 3m. Nq is equals to 9 into m. Here m is equals to 3q some integer. Let's see case 2. So case 2, 3q plus 1. According to the question, taking q both sides, we'll do the same thing which we have done in the previous part or case 1. Only we need to change the number. Nq is equals to 3q plus 1 whole cube. Now you know whole cube of any number. A plus b whole cube is equals to a cube plus b cube plus 3a square b plus 3ab square. This identity will be used in this part, or just open this bracket. We have now nq is equals to 3 3 is 27 q cube plus 3 3s are 9, 27 q square plus 3 3s are 9 q plus 1. From this part you can see 9 can be taken common. Nq is equals to 9 is common. So 3qq plus 3q square plus q and plus 1. And this will be taken as another integer m. So we write 9 m plus 1. Case 2 is done. Now we discuss case 3. Next case is case 3. N is equals to 3q plus 2. According to the question, taking q both sides, as we have done in the previous cases, nq is equals to 3q plus 2 and whole cube, and we have discussed the property already, formula, how to open this. Therefore I am going to do it directly. 3 3 is 9, 3 is 27 q plus 9q square, 37 2 is 54 q square plus 3 3 is 9, 2 is 18 q plus 2 to the 4 to the 8. So you can see from this 9 can be taken common. So you can see 9 can be taken common. So 9 is outside of the bracket. 3qq plus 9 6 are 54 q square plus 9 2 is 18 q and plus this 8. Now this number will be written as another integer m. 9 m plus 8. So from all the three cases you have seen that either the cube of any integer is in the form of 9m, which was in case 1, 9m plus 1, case 2, and 9m plus 8, this is the case 3. Here you can write, here m is equals to 3qq plus 6q square plus 2q, some integer. Therefore from cases 1, 2 and 3, we can say cube of any integer is of the form 9m plus 1 or 9m plus 8. Hope the solution is simple and it is clear to you all. If you have any doubt, you can drop me a comment. I'll try to make a video for that. Enhance your learning. Get a good score in this coming board examination. Good luck. See you in the next video.